In this activity, we'll be studying exponents. Exponents are a shorthand way to write a number multiplied by itself a number of times. Instead of writing 3 times 3 times 3 times 3 times 3, we can write 3 to the 6th power. A whole number exponent indicates the number of times a base is used as a factor. The base is the number that you're multiplying by itself. The exponent, or sometimes called an index or a power, is the small number written to the top right of the base. When there is no exponent present, it is understood to be 1. A number 14 to the 4th power written with an exponent is an exponential form and is written as 14 to the 4th power. We use exponents for powers of 10, and there's a shortcut way to write powers of 10. The number of zeros tells you the exponent. For example, the number 1,000 would be written as 10 to the 3rd power. The exponent is 3 because there are 3 zeros. The number 100,000 would be written as 10 to the 5th power because there are 5 zeros. There are 2 exponents that have special names, squares and cubes. A whole number is a square, a perfect square, and the exponent is 2 if it's the product of a whole number times itself. For example, 36 is a perfect square because it is the product of 6 times 6, or 6 squared. 100 is a perfect square because it is the product of 10 times 10, or 10 to the 2nd power. Here is a list of some perfect squares: 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And the squares is actually based on the area of a unit square, which is side times itself. That's why it's called a square. A whole number is a cube, or a perfect cube, if it can be written as the product of 3 whole number factors that are equal. That is a whole number raised to the 3rd power. For example, 27 is a perfect cube because it is the product of 3 times 3 times 3, or 3 raised to the 3rd power. 64 is a perfect cube because it is the product of 4 times 4 times 4, or 4 raised to the 3rd power. The reason it's called a cube is it has to do with when you're looking at a unit cube and you're looking at the volume, finding the volume, which is the length times the width times the height. And I'll go over more about where these names come from in class. But here's a list of some perfect cubes: 8, 27, 64, 125, 216, 343.